The public lecture that I attended was about 100 Years of Einstein's Gravity, Inquiring Minds of Public Lecture. We didn't discuss Einstein's relativity theorem, but it was very interesting because I was interested in this topic after I watched the movie Interstellar and had discussion in my AP Physics class in my senior year. So the lecture explained what does Einstein's gravity means to astrophysicists. The answer is, it is cosmology and expanding universe, all about related to black holes and gravitational waves. There was a very interesting saying in the lecture that grabbed my attention. I realized that all the natural phenomena could be discussed in terms of special relativity except for the law of gravitation by Einstein 1907. It was a very interesting theorem because it basically says time on the Earth can be different from that of on the other planets except the Earth. It can directly be related to the time distortion and vastness of the time. So let's have an example. If Jose is at the upward of the rocket and Maria at the bottom, even if they travel in the same spaceship in the universe, moving clock ticks slower and Maria is younger than Jose, who is at the upward in the spaceship. However, when the rocket moves heading to the direction towards Jose's and accelerate to that direction, Jose is younger than Maria. This amazing and weird theorem is directly related to Einstein's general and special relativity theorem. I just had very minor detailed information about the Einstein's theorem before the lecture, but after this lecture, it all summarized very well in my mind, and the topic and explanation was fascinating enough for me to have some research on this topic and choose my wiki page topic as this. There was another new concept that I learned in this lecture: spaghettification. This term sounded very weird because it has spaghetti in physics term, and spaghetti sounded it has nothing to do with physics. When I googled the term, it said in astrophysics, spaghettification is the vertical stretching and horizontal compression of object into long thin shapes, rather like spaghetti, in a very strong non-homogeneous gravitational field. It is caused by extreme tidal forces. So in other words, spaghettification is a theoretical process of an object getting stretched by the gravity of a black hole. This funny theorem and term basically says that when you feel the force of gravitation, your feet feel faster and you stretch out. Here are some interesting photos where you can see the person stretched out like spaghetti noodle. It was new concept and idea for me that I couldn't even imagine before this lecture. All of these concepts link to a big concept which was a majority part of the lecture: black hole. Black holes are seen because of the matters are interacting with each other, or stars are losing the matter of the black hole. If you think or imagine how big is the sun, well, the black hole is 4 million times greater than the sun. When black holes collide, they form gravitational waves, and when two of them collide, they make a sound of ultraviolet aurora kind of, which was really cool. It was like the sound you can hear when you go deep down the sea and there are buzzing sounds around your ear. These gravitational waves are important to astrophysicists and scientists because the waves answer questions like, is general relativity the correct theorem of gravity? How does matter behave under extreme gravity? Or are black holes really the black holes of general relativity? So how should you detect and analyze these gravitational waves? Physically, gravitational waves are strange, which is delta L divided by L, which is the concept that we dealt with in class during this semester. However, there are some challenges of detecting gravitational waves. So with the equation above, we set delta L divided by the original length of the waves, which is L, equals to 10 to the negative 22nd, and this is equivalent to measuring distance between the sun and proximity Centauri to less than the width of a human hair. This is very detailed and the exact number you can get when you do the calculations. However, with some possible errors with this answer from the equation, there is an equivalent called LIGO, which stands for Laser Interferometer Gravitational Wave Observatory. There are some in the States in Hanford, Washington, and Livingston, LA. This public lecture was very interesting and I would like to attend it again if I have any other opportunities too.